Hi, our presentation is on Francis Viete's approximation of pi. I'm Nicole Clizzy, and my assistant Orion Thompson Vogel. First, we'll start out with explaining how Viete came up with approximating pi. I've drawn up 3 polygons within circles, a 4-sided, 5-sided, and 6-sided. As you can see, as we increase the number of n sides, we can better represent a circle. So, as n approaches infinity, the area of the polygons becomes that of a circle. Also, the polygons can be broken up into identical triangles. So the area of the polygons is the triangle times n sides. So here we have a triangle AOB, which is within a circle, which also represents one side of an n-sided polygon. So I've extracted the triangle AOB from the circle, and we want to focus on the area of this triangle. And we know that the area of a triangle is 1/2 base times height, and we know that the base is equal to the radius. So now we have to find the height. So now to get the height of the triangle AOB, we're going to use the sine of 2 beta equals h over r. So to rearrange to get h, we get r sine 2 beta. Going from there, we're going to use a trig identity. So now we get h equals r sine beta cosine beta times 2. So now that we know the height, we can get the area of the triangle AOB, which is going to be equal to 1/2 r, the base, times r sine beta cosine beta times 2, which is the height. So minimizing that, we are going to get r squared sine beta cosine beta. So that is going to represent the area of the triangle AOB. So now that we have the area of that triangle, we can get the area of the polygons with n sides. So it's going to be n sides times r squared sine beta cosine beta.
We just examined the area of an n-sided polygon. Well, now let's look at the area of a 2n-sided polygon. The area of an n-sided polygon was found by examining the triangle AOB. Well, for a 2n-sided polygon, we want to look at the triangle AOC. So looking at this triangle, we can find the area of this triangle in the same method, using the same methods that we did before. And so we find that the area of this triangle is equal to 1/2 times r squared times sine beta. So the area of a 2n-sided polygon is equal to 2n times this area I just said. So that's equal to n times r squared times sine beta. Now, let's look at the ratio of the area of the n-sided polygon over the area of the 2n-sided polygon. So plugging these in, we see that everything cancels except for a cosine beta. So this is really nice. Well, what happens when we look at the area of an n-sided polygon over the area of a 4n-sided polygon? Well, we can decompose this into the area of an n-sided polygon over the area of a 2n-sided polygon times the area of a 2n-sided polygon over the area of a 4n-sided polygon. So we know the left component, but we don't know the right component. The right component, though, however, we can sort of figure out by re-examining what we just did. If we draw an angle bisector from O to a point on the circle between A and C, such that the angles are beta over 2, then we can replace all of these betas with betas over 2. And so we know that the ratio of a 2n-sided polygon over a 4n-sided polygon is equal to cosine beta over 2. So thus this product is equal to cosine beta times cosine beta over 2. Now that we've looked at the ratio of the area of an n-sided polygon over the area of a 4n-sided polygon, well, how about let's look at the ratio of the area of an n-sided polygon over the area of a 2 to the k n-sided polygon. Okay, so let's first look at the area of a 2 to the k times n-sided polygon. So if we bring k to infinity, we basically get a circle, right? Because it's a polygon with an infinite amount of sides. So the area of this, as we know, is the area of a circle. And so the area of a circle is pi times r squared. So we can plug that into the expression along with the area of an inside polygon. Now note we're using a different expression for the area of an inside polygon. This is before we applied the trig identity, but that's it. There's no super tricky stuff going on. So this we know is equal to cosine beta times cosine beta over 2 times ... times cosine beta over 2 to the k, because every time you bisect beta into two different angles, which are equivalent. So we can rewrite this expression in terms of pi. So we get pi is equal to 1/2 times n times sine of 2 beta over cosine beta times ... times cosine beta over 2 to the k. Now using that formula we came up with for pi, seen at the top right, we can start plugging in things. Now Viete originally used n equals 4, aka a square, to start with. And so we can see that beta is going to be 45 degrees or pi over 4. So plugging in everything, as seen right here, we can see that the sine becomes 1 because sine of pi over 2 is 1. And then that's times 4 over 2. 4 over 2 is 2. And then the bottom portion can be decomposed using the half angle formula. So applying that formula, we get that pi is equal to 2 over the square root of 1/2 plus 1/2 times the square root of, and so on. It goes on forever, basically. Take 93.
And that was Viete's approximation of pi.
Thanks
for watching.
Is that good?
I think so.